This lesson covers applications of systems of linear equations. This means we'll be looking at problems that deal with two variables. Sometimes when you're dealing with problems, it's nice to have a process in mind, a place to start. You may start by digesting the information in the problem by drawing a diagram and assigning variables. Once you've completed that, you can start looking at the various truth statements that are included in the problem, and you can create some equations. Once you've done that, you have the process of solving them, checking the answer, and stating the final solution. So let's take a look at some examples of how this works. The first problem tells us that there's a 30-foot rope. It's cut into two pieces. One piece is 3 feet longer than twice the other piece. They want us to find the length of each piece. Now, notice it hasn't been cut exactly in half, so we don't know the lengths of the two pieces. Since we don't know the lengths of the two pieces, we can call those x and y. So you can let x be the length of piece x and y be the length of the y piece. You'll notice that the first sentence tells us that the two pieces together combine to a 30-foot rope. This actually tells us the first equation that x plus y is a total of 30. The second sentence gives us more information about how these pieces are related. So it tells us that one piece, so say x, is equal to 3 feet longer than twice the other piece, so twice the y piece. So notice we have now two equations with two variables, and we have three different ways of solving them. We could solve by substitution, we could solve by graphing, we could solve by the addition method. Notice that in this case, x is already solved in the second equation, so it would be quickest to take this expression, 3 plus 2y, and replace it with x in the first equation, which would be completing it by substitution. However, you'll also notice that in the past you've seen the exact same problem, and what you did in the past was you said, well, one piece is going to be x, and the other piece is going to need to be 30 minus x. What you were actually doing is using substitution for this same set of equations. What you were doing is you were solving the first equation for, say, the other piece, y, which was equal to 30 minus x. So you were looking at 30 minus x as one piece and x as the other piece. So you may also do that and plug in the 30 minus x to the second equation. Since we have this written down, let's go ahead with it. So we're doing substitution by solving the first equation for y. Notice you can do it in many different ways. Please feel free to do it in any way you wish. In this way, the way that relates most to what we were doing before, we would have x is equal to 3 feet longer than twice the other piece, which is 30 minus x. Now let's continue and solve that. We get x equals 3 plus 2 times 30, 2 times negative x. That's 60 minus 2x. You can solve this. Add 2x to both sides, you get 3x equals 63. Divide by 3 and you get 21. So now we can check our answer and see if it's reasonable. Could one of these pieces be 21? Sure. What would the other piece be? Well, the other piece would be 30 minus that 21, which is 9. So the other piece should be 9. Does that work? 21 plus 9 is 30. Great. And 3 feet longer than twice the other piece. So 9 doubled is 18 plus 3 is 21. So you can state your final answer and say that the rope was split into 21 feet and 9 feet pieces. Let's take a look at another example. In this example, we have a 50-meter path surrounding a rectangular garden. So let's start with drawing a diagram because it's good to visualize what they're talking about. So start by drawing a rectangle. We also know that all around this red line is 50 meters. So that's going to tell us a total length. Now, we know that we have a width and a length, and that the width is 2/3 of the length. They want the area, but in order to find the area, we need the length and the width. So let's let our variables say W be the width and L be the length. So then you have WW length. Altogether, the total length could be represented as twice the length and twice the width, giving us 50. So that comes from our first sentence. The second sentence tells us a certain relationship between the length and the width. They tell us that the width is 2/3 of the length. So directly from the second sentence, we have translated it into the second equation. Now, we can fuse these two equations by taking any of the methods of solving equations possible. In this case, I would highly suggest, because one of our variables is already solved, we could use substitution and plug in the W expression into the first equation, which would give us twice the length plus twice the width, which is 2/3 the length, equals 50. Now let's take a look at how to solve this. We've got twice the length plus 2/1 times 2/3 times L, which is 4/3 L, equals 50, just by multiplying these fractions. Now we're adding up 2 plus 4/3 because these are like terms. 2/1 is the same as 6/3. 6/3 plus 4/3 gives us 10/3 length equals 50. To find the length, we could multiply by the reciprocal on both sides to eliminate what's by the L. That gives us, when we simplify that, we get 15 to be the length. We can go back to what the width was. The width was 2/3 of the length. Find that, and that gives you 10 for the width. Let's check that. Double 10 and double 15. Do you get 50? I think you do. So your final answer can be find the area of the garden. So therefore, the area of the garden is length times width, which is 15 times 10, which is 150 meters squared. Let's take a look at this next example. Here we've got regular admission for a movie is $8 per ticket. Seniors only pay $6 per ticket. We've got a total revenue given. So we've got total money. And we've also got a total number of people given. Let X be number of regular admission tickets and Y be the number of senior admission tickets. Now, how do we create an equation for the total amount of money? Well, we know that $8 per ticket for regular admission would be 8 times X, because X regular admission tickets were purchased, and we add that to the amount of revenue coming from the seniors, which would be $6 per ticket, and seniors were Y. So, together, the money that the regular admission tickets gave plus the money that the senior admission tickets gave would total to $1,440. The total amount of people is represented by 190, and our variables represent the number of people. So X plus Y would be adults plus seniors would give you 190 people. So now we've got two equations that we can solve using various methods. You could use substitution, you could use the addition method. Notice that we want to find out how many seniors attended. So we really want to find out Y. Therefore, we could use the addition method to eliminate our X values. So, if we want to eliminate the X values, we want to multiply the bottom equation by -8. Multiply everything by -8, you get -8x minus 8y, and the 190 becomes multiplied by -8, which is -1520. Let's add those up. 1440 minus 1520 gives us -80. And 6 minus 8 gives us -2y. That gives us y equals 40. Therefore, there should be 40 senior admission tickets sold. So 40 seniors attended. If you'd like, you can check to see if everything works out. If 40 seniors attended and there were 190 people, that means we had 150 regular admission times $8, and we had 40 people with senior admission times $6. See, does that equal 1440? And yes, it does. Let's take a look at this investment problem. Here we have a total amount of money to invest in two different accounts. So we have $5,000 to invest in two different accounts. Let's draw a picture here. So $5,000 total, and that can be invested in two accounts. So we got some here and some here. So let's have the dollars here and the dollars here. So we don't know how much is invested in each one, I don't think. Let's keep reading. The first account earns 4%, second account earns 5%. How much money should be invested? There we go. They're asking us how much money should be invested, so we don't know. So let's let X be the dollars invested in the 4% account, and Y be the dollars invested in the 5% account. So we've got X dollars here, Y dollars here. And the interest we make is 4% interest on this one, and we make 5% interest on this one. This is simple interest, so what that means is we take 4% of the dollars directly for how much is being made in 1 year. So if we make 4% on X and 5% on Y together, we will be making $218 of interest. So let's have interest written in blue. Let's make an equation that relates this interest. So how do we take 4% of X? Taking 4% of X would be multiplying it by 0.04. How do we take 0.05% of Y? We take 0.05 times Y. Add those up, you'll have the total interest equation. You can also relate just the plain dollars. The total dollars would be X plus Y equals 5,000. And there we get two equations. So You could either solve this by substitution or the addition method. You can try out many different ways and see if they all work the same. Let's take this and apply what we used to do to this and look at substituting for y. So let's say y equals 5,000 minus x. So notice that that tells us that there was x dollars in this account and 5,000 minus x dollars in this account. So if we take 4% of our x dollars plus 5% of our 5,000 minus x dollars, that should give us the total interest of $218. Really try to make sense of this so that you see what each of these expressions really means. Let's continue to solve this. We get 0.04x plus 0.05 of 5,000, which is 250, minus 0.05x is equal to 218. Continue solving that, you get negative 0.01x is equal to 218 minus 250, which is negative 32. That means x is 3,200. Now, what that means is we should have $3,200 in this account. And what's 5,000 minus 3,200? Well, that's 1,800. Now check if that works. 3,200 and 1,800 makes 5 grand. Take 4% of 3,200, that's $128, and 5% of 1,800, that's $90. Add those together, and you get $218. Therefore, our final answer would be invest $3,200 in the 4% account and $1,800 in the 5% account. Here's another similar problem. We've got percentages and totals as well. So similarly, we're going to be looking to create an equation that relates the percentages and an equation that relates the totals. So we've got 50-ounce sugar solution that is 34% sugar made from 20% sugar and 40% sugar. So you have some 20% sugar mixed with some 40% sugar in order to make a total of 50 ounces of 34% sugar. Let's say that sugar is blue. So how much sugar is in the total? Well, 50 times 34% is 17 ounces of sugar in the total. So you know that 17 ounces is split somehow within what is making this total, which is the 20% solution and the 40% solution. So they're asking us how much of each type of solution is used. So let's say, let x be the number of ounces of 20% sugar solution, because they're asking how much each type of solution, not of how much sugar is in each solution. And y be the ounces of 40% solution. So we've got x ounces total here and y ounces total here. Let's consider sugar now. How much sugar is in the first one? Well, 20% of x would be the amount of sugar in there, and 40% of y would be the amount of sugar in there. Let's make two equations. One of them is going to relate the total, which is red. So that's x plus y is 50. The other equation is going to represent the sugar amounts. So the first sugar amount was 20% of x, second was 40% of y, and together that made 34% of 50, which was 17. Now we've got two equations. Let's solve these equations. we've used substitution a few times, so let's see how we would use elimination or addition to solve this. So let's eliminate one of our variables. You'll notice we have the question of finding both, so it doesn't really matter which one we eliminate. So let's multiply the top equation by negative 0.20. So that'll be negative 0.20 and times negative 0.20. And what's 50 times negative 0.20? That's negative 10. So let's add those up. We have negative 10 plus 17. That's 7. And then our x's disappear, and we have negative 0.2y plus 0.4y, which is 0.4 minus 2, which is 0.2y. So 0.2y should equal 7, therefore y should equal 7 divided by 0.2, which is 35. So now we can go back to our original equation, which was x plus y is 50, and consider what would happen if y was 50. Therefore, x would be 50 minus y, which is 50 minus 35, which is 15. So let's take a look. Does this work? Could we have 15 ounces of 20% and 35 ounces of 40% to make 17 ounces of sugar total? Let's take a look. 15 times 0.2 is 3. So there's 3 ounces of sugar here. And 40% of 35 is 14 ounces here. So we actually have 3 grams of sugar and 14 grams of sugar, giving us So we have 3 ounces of sugar and 14 ounces of sugar, giving us a total of 17 ounces of sugar. Great, that works. Therefore, we want to use 35 ounces of 40% sugar solution and 15 ounces of 20% solution. Let's take a look at this last problem here. Here we have a plane flying. So we've got some rate and time and distance. So a plane is flying 300 miles in 2 hours with a tailwind. So let's draw a picture. So he's flying 300 miles in 2 hours with a tailwind. So what that means is he's flying with the wind. Then he comes back against the wind. It takes 3 hours because it's tougher and it's the same distance. So there's an opposite wind against the wind. They want us to find the rate of the plane in calm air and the rate of the plane and the rate of the wind. So they've given us the 2 variables that they want us to use. So let's let x be rate of plane in calm condition and y be the rate of the wind. Now, let's see how we can make an equation out of this. We know the underlying formula of rate times time equals distance. So, let's consider the first case, the first scenario. We have a rate. Now, the rate going there with the wind, we need to think about that. We're going to figure out our rate. We're going to multiply by 2 hours to get 300 miles. and this will be going with the wind. So that's our first picture. Our second picture is going against the wind. We need to figure out a rate, multiply it by 3 hours to get 300 miles. So now we need to talk about how to find the rate going with the wind and how to find the rate going against the wind. We know that x is the rate of the plane in calm conditions and y is the rate of the wind. Recall from the past, when you figure out a rate with a force and against a force, you want to always start with the predominant rate, the predominant speed, which is the rate of the plane. The plane is going to be, well, it should be faster than the rate of the wind, otherwise the plane shouldn't be in the air. So let's start with x as the speed of the plane, but then when it's going with the wind, it's being sped up by the rate of the wind. However, when it's going against the wind, it's being slowed down by the rate of the wind. So there we have it. With the wind, we've got x plus y. Against the wind, we've got x minus y. And we've got two separate equations, which we can now combine using our solving techniques. So let's go ahead and solve these equations. This gives us 2x plus 2y is equal to 300, and this one gives us 3x minus 3y is equal to 300. So let's go ahead and let's use the addition method. So we could multiply the whole top equation by 3 and the whole bottom equation by 2, therefore giving us 6x plus 6y is equal to 900, and 6x minus 6y equals 600. Add those up, you'll get 12x, y's cancel, 900 and 600 is 1500. So that would give us 1500 divided by 12, which is 125. Let's now continue and plug that back in to say the first equation, which told us 2x plus 2y is equal to 300. So twice 125 plus twice y would be 300. Twice 125 is 250. Take that away from 300, you get 2y is equal to 50, and therefore y is 25. So what that tells us is that x is 125, which is 125 miles per hour, is the speed or the rate of the plane in calm conditions. And 25 miles per hour is the speed or the rate of the wind. You can go back and check if that makes sense.